Consumers are demanding faster charging for their electric vehicles, and that means taking a hard look at the link between the charging inlet and the battery. That's why interface management is essential throughout the entire charging harness. To charge faster, the industry is quickly moving from currents of 500 amps to 800 amps and higher. But higher currents generate more heat at every contact interface along the charging harness. It all starts where the charger meets the inlet, at the normal force contact between the coupler and the pin. In this example, current then moves through a bolted interface between the inlet pin and a bus bar, adding some resistance. Given the properties inherent in its material, the bus bar also adds a small amount of resistance and generates heat as current flows, before the current encounters a welded interface between the bus bar and a high-voltage cable, which adds some resistance as well. The cable is then welded to a battery connector terminal. The resistance of the welded interface is much lower than the normal force contact that ultimately delivers the current to the battery. Managing heat at each interface along the way is key to optimize charging performance. Interface management is equally critical for AC charging. Similar to DC fast charging, the first interface in AC charging is at the point where the coupler socket contact meets the pin. In this example, the next interface is a mechanical crimp between the inlet terminal and a cable. The cable itself adds some resistance given its inherent material properties. As current flows toward the connection at the onboard charger, there may be welded interfaces or possibly crimps on either side of a normal force contact. Every electrical interface adds resistance, both in the charging harness and in the overall power distribution network. High resistances can result in slower charge times and contribute to consumer concerns about range anxiety. Managing the heat generated with reliability and integrity at each interface is key to optimized charging performance.